Hello everyone. Our experiment today is LM1, the mechanical equivalent of heat. The aim of our experiment is to determine the mechanical equivalent of heat. Now we move to the basic theory. According to the Black principle, if we mix hot and cold water in an open container, for example a bucket, heat transfer from hot water to the cold water. In this case, the bucket is a non-isolated system. The Black principle states that in an isolated closed system, heat released by a high temperature object equal to heat absorbed by low temperature object. So Q out express heat released by high temperature objects equal to Q in is a heat absorbed by low temperature object. Then the energy released by the electrical wire E equal to the square of the current time resistance and multiply by time. Based on calorimetry principle, when a body at high temperature is brought in a contact with another body at lower temperature, the heat lost by the hot body is equal to the heat gained by the cold body, provided no heat is allowed to escape to the surrounding. This is known as a mixture method principle. The energy that calorimeter system receives from the wire, Q equal to W multiplied by the difference temperature between T2 and T1, which is T1 is initial temperature of calorimeter with water, T2 is the final temperature of the system, and W equal to the mass of calorimeter times specific heat of calorimeter plus the mass of water times the specific heat of water. Material and tools. The first one is electrical calorimeter. Then a thermometer, a stopwatch, a balance of torque, DC ammeter, DC voltmeter, sliding resistance, and then cable connector probe, also water. The procedure. The first thing you have to do is to measure the mass M1 of empty calorimeter and stirrer. Put the empty calorimeter and stirrer in the balance of torque, and then measure the mass M1 by setting the scale of the balance torque. Remember to write down the value of the mass M1. And then after that, you can take out the calorimeter and the stirrer, and you can open it and pour the water into the empty calorimeter, and put again the stirrer, and you have to measure the mass M2 of calorimeter containing water, a quarter of volume, along with the stirrer, and put it again in the balance of torque. And you have to determine the value of M2 by setting the scale of the balance torque. Remember to be careful in determining the value of M2, because you have to set the scale in a correct position in the balance state. Okay, after you measure the M2, then you can take out the calorimeter from the balance sort and put on in the top of table, and also you can put the thermometer. After 1 minute, you can record its temperature, and this is T1. T1 is initial temperature of calorimeter and the water. You can wait after 1 minute to read the measure of T1 on the thermometer. As you can see there, the stopwatch is recording the time for 1 minute. After that, you can read the temperature on the thermometer scale, and you write down it as T1. The next step, you have to make the electrical circuit as shown in the figure on the manual experiment book or in the right side of the monitor. As you can see there, from the electrical circuit on the manual book or in the monitor, as you can see in the above in the right side, you have to make the circuit the electrical circuit in the correct position, from the calorimeter to the ammeter, DC ammeter, AC voltmeter, and also sliding resistance. You can connect all the electrical circuit by using the electrical circuit probe, the yellow one, as you can see there. After the circuit is ready, then you can arrange the RG. The R is still not immersed in the water, so that the ampere meter reading shows 1 ampere of the current. And then in the state R immersed in the water, the calorimeter is closed. Connect the current in the circuit and steer gently so that the heat from the R is evenly absorbed by the water and the calorimeter, while observing the increase in temperature on the thermometer. So you can steer the water so that the heat that they got from the R will immerse in the water. As you can see there, you have to watch carefully the thermometer. And record the temperature after rising ±4 degrees Celsius, and also note the length of the time the current flows and the voltage or current in the multimeter. You can see there, you can observe the temperature in the thermometer after rising 4 degrees Celsius, and also you have to record the time, and this is for T2. Please repeat the experiment for the currents 1.5 and 2 ampere. After you did the procedure, then you will get the data. As you can see in the video, you will get the M1. M1 is the mass of the vacant calorimeter and the stirrer in grams, and then you will get M2. M2 is the mass of the calorimeter and the stirrer also with the water inside it. And after that, you also will get the T1. T1 is the initial temperature of the calorimeter with the water in Celsius. After that, you did some variation in the current. You get I1, I2, and I3 in ampere. And also you will have to record the time in second for each part, so that you will get the T2 for each current, for each the variation of the current in Celsius. And also you will get the voltage for each part also, V1, V2, and V3 in volt. Here is your task. For your report, after you got the data from the teaching assistant, you have to determine the mechanical equivalent of the heat from the system with various current you use, and then you have to compare the values you get with the provision in the literature, and then you have to make some comment of your result by discussing and put it in the report. Good luck and see you in the next experiment. Thank you.